Hello teacher King, my name is Boonchai No Padivet, student number 00471. And I'm here to do two conceptual questions. Thank you. Okay, I'll start with question number one. Here is a picture of magnetic field and electric field in the picture below. So the question is like, what statement is correct? I'm gonna start my solution by introducing that if there is a current here, there will be a magnetic field around it, and this is okay. So with this, you have to know the relationship between current and electric field. So actually, current is related to electric field here. So it's a in the picture the if the magnetic field shape like this, so the current would be to the above, and if the current is above, so dE by dt is to here, to the above end. That means the E in the figure A is decreasing, so here. And another one, if the magnetic field come that way also, the current should be here. And since the current is here, that means the rate of change of electric field is downward. And when the change of electric field is downward, that means the electric field is also decreasing. So the answer is number 2. And the next one, I will choose number 3. So here is the variation of electric field, okay, perpendicular to an area. What is the greatest displacement current? Okay, like just as I say, so displacement current is perpendicular to the direction of the E by dt. So to choose this, since I don't think the question is like focusing on the sign, so I guess it's mean the value, not care of the direction. And from here, I just choose the one that have the high rate, like the high slope with the high value of slope. So it's over here. The slope is 2 Newton per Coulomb per 2 millisecond. Oh, but actually, I mean, it doesn't matter if it's care about the direction or not, because like here the slope is still the maximum, even though like yeah, I mean here the slope is minus, but I know the value of that minus, like absolute value, is still less than this one. So yeah, I'll choose this one. Here the result is 1 million Newton per Coulomb second. Okay, so it have to find the displacement current. So I'm look into the internet and okay. So displacement current is epsilon naught fuck electricity fuck by dt. And electricity fuck, since the area is constant, so it should be I have to find what is epsilon naught is equal. Okay. Uh, 8.85 times, yeah, and area is 2.0. Yeah, and this is the value in ampere. Let me check.
Okay. Good morning, teacher. My name is Kirsten Arilo. You can call me Nenno. Now I go to solution. Give the solution in question 9. A parallel plate capacitor has a plate area of A equal to 0.250 square meter and a separation of 0.0100 meter. What must be the angular frequency omega for a voltage Vt equal V0 sine omega t, with V0 equal 100 volt to produce a maximum displacement induced current of 1.00 ampere between the plates. Okay, now we have a sorry. Now we have A equal 0.250 square meter, and we have D equal 0.0100 meter, and we have Vt equal V0 sine omega t, and V0 equal 100 volt ID max, or displacement induced current, maximum displacement induced current equal 1.00 ampere. From ID max of Maxwell modification equal epsilon 0 partial differential between frac E and by dt. Frac E equal E dot A. Partial dip by dt. Now consider E and A. Direction of E and A. we know the area direction is perpendicular from the page area, and E is this page. We know A direction in this, and E move page to page, and then E and A have the same direction. Then theta between direction E and A is 0. Then when dot product with theta equals 0 degree or 0 radians, it mean cos theta equal 1. Then is epsilon 0 multiplied with partial dip of EA by dt equal, but A is the constant value from this equation. Then ID max equal epsilon 0 A partial dip E by d epsilon t. Sorry, partial dip E by dt. Form is a star equation for based on the static electrical. We know E equal dV. No, sorry. V equal dV, dE. That means E equal V by D. Then ID max or maximum displacement current, induced current equal epsilon 0 A partial diff of V by D by dt. But D is constant value is equal 0.0100 meter. That's mean ID max equal epsilon 0 A by D multiplied with partial dip V by dt. From V equal V0 sine omega t by dt. That means V0 is the constant value same. Same with A and D, but it's another meaning. Okay. Then ID max equal epsilon 0 A by D multiply V0. Sorry, epsilon 0 A V0 by D and partial dip or now it's only one variable. Then I use D sine omega t by dt. This differential is equal omega cos omega t. Is equal epsilon 0 A D V0 and D plus sorry, epsilon 0 A V0 omega cos omega t by D equal ID max. Okay. And move them to the left. Use this. Okay. Now we got omega equal ID max D by epsilon 0 A V 0 cos omega t. Okay, now consider in this equation what is the I have of this equation is if I want ID max, that means cos omega t cosine omega t must be max because if I consider omega 0 is constant value, A, V 0, omega, and D is constant value too. Is can variable is cos omega t. Then cos omega t must the maximum value for the ID max is maximum value too. But the cos omega t have the maximum is 1. Then this is 1. Epsilon 0 is 8.85 multiplied 10 power negative 12 and and is omega equal 4.52 multiplied with 10 power 7 radians per second. Okay. For the next question is question 11. A parallel pairs capacitor with circular pair of radiance R is being discharged. The displacement current to a central circular area parallel to the pair and with a radius R by 2, the half of R, is 2.0 ampere. What is the discharge current? Is answer A, but I gonna show the solution. Now, I have the circular pit. Oh, sorry. It's circular pit. Then, when I draw the picture of them is this. And I want to another is this. Okay. And then being to discharge the displacement current in this. Okay, now we have ID for the half of R equal to 0.0 ampere. Okay, what's in the ID? Half of R is equal epsilon 0 partial dip frac E by frac T. Sorry, partial dip frac E by dt. Is the same as the previous question. Is frac E equal E dot A by dt. And the direction E and A is the same in the previous question too. Is the parallel then and then theta is equal 0 degree. Then cos theta equal 1. ID R, the half of R equal epsilon 0 partial dip E A by dt. Okay. A is a constant value. That means epsilon 0 A is have only one variable, but E in term T is something in term T. Something function in term T. Yeah. And then I change the partial dip to the standard dip is dE by dt. Okay. Now epsilon 0 multiply A is the pi, the half of R square, because this current displacement displacement current in the supra in R, the half of R. Okay. Multiply dE by dt. I let them into the equation 1. Okay. And the ID is the all of the page in all of the page is just the same equation, the same equation with ID the half of R is epsilon 0 partial dip EA by dt is epsilon 0 A dE by dt is equal epsilon 0 pi R square dE by dt. From the problem is don't give the dE by dt is the change the this ratio and then it mean dE by dt is a uniform in the all of pairs. Then dE by dt is equal. Then 1 by 2 is ID the half of R by ID equal epsilon 0 cancel together. Pi is 2. Okay, I write them in this. Okay, pi by 2 square dE by dt by epsilon 0 pi R square dE by dt. This value is cancelled together, and epsilon 0 pi is cancelled together. Cancel to R square to cancel to R square is the right hand side have only a quarter, but ID the half of R is 2.0 ampere by ID equal a quarter, then ID equal 8.0 ampere. Okay. For the next question is the last of my solution is for the displacement current produced between the pairs of a discharging capacitor for which the charge varies as the equation talking about Q and T is the QT, Q in the time T equal Q0 is the initial charge multiply with E power negative T by RC. by C is the capacitance of capacitor, and R is the resistance of the circuit through which the capacitor is discharging. Uh, in this problem, one ID again. Okay, but I'm gonna use another equation from the two previous problem. In two previous problem, I used the equation ID equal epsilon 0 partial dip for E by dt. But in this, I'm gonna use dq by dt. It's the simple formula for the current phi current when we have the charge and the t in the tab. Okay. ID equal the differential between Q0 multiply E power negative T by RC, then by ET, R and T. Okay. Q0 is the initial charge, then its constant value, and multiply differential between E power negative T by RC. Oh, I'm so sorry. It's the I in the Y. From the discharging capacitor is not ID. I'm so sorry. I forgot it. Okay. By dt. From this, I gonna use the shell rule, but I'm the fast and I gonna use I'm so sorry, not forgot in the previous sentence. Okay. I have consider in this differential it's gonna use the shallow, then the value of them is equal E power negative T by RC multiply with 1 by RC. It's gonna use shallow that I talking into the yeah, and is equal negative Q0 E power negative T by RC by RC. But why the current is the negative is because the first in the Y is no because the charge is decreased, then I is increased, is contrast, and then is have negative for the top said about I is increased. Then if I use if I want ID is equal I sorry is magnitude of I is equal Q0 E power negative T by RC by RC. Okay. Yeah. Yes. Then ID in time T equal Q0 E power negative T by RC and then by RC again. That's the answer. Okay, thank you for attention. If I have some problem, I am so sorry. or there.